So what you do is, first you take the first order derivative. So product rule, u is equal to x, v is equal to e raised to minus x. U dash is 1, u dash is 1.
And all further product rules.
V dash is what? E raised to minus x into minus 1, correct? Because so therefore dy by dx is equal to v into u dash minus u into v dash plus, correct, x into minus e raised to minus x. So that is e raised to minus x minus x e raised to minus x. Remove e raised to minus x common, 1 minus x. You to make this equal to 0. So that means this is equal to 0 or 1 minus x is equal to 0. Now this is no solution. Remember, there is no solution. X is equal to 1. This is the only solution. Now this is the position of the stationary point at x is equal to 1. And the nature, when you're finding, how do you find the nature? You'll put this in the second order derivative. Now your d square y by dx square is your second order derivative. Correct? Now you'll take your u as what? E raised to minus x. This is now you'll do. You'll take the derivative of this. You'll take the derivative of this function. So that's your u. Your v is 1 minus x. So u dash is minus e raised to minus x because of the chain rule. V dash is minus 1. So v into u dash, u into v dash. Correct? You can remove e raised to minus x common. You will be left with 1 minus x minus 1. Okay? So what will that become? So this into this. Correct? Both are minus. I made a sign mistake. Both are minus. So that means this will become minus 1 plus x minus 1. So e raised to minus x minus 2. Now you put this answer in the second order derivative. You put x is equal to 1 in this. If you put x as 1 in this, 1 minus 2. That's minus 1 over e. Because e raised to minus is 1 over e, which is negative. What is the value of e? E is approximately equal to 2.718. It's a positive number. It's approximately equal to 2.718. That value is not required. You leave your answer as e only. So minus 1 over negative. If it's negative, then what does it mean?
Then it's like negative.
Local maximum.
Oh yeah.
So there's a local maximum at x is equal to 1. If your second order derivative is negative, so you take your first order derivative, make it equal to 0, solve it. The answer that you get, put in the second order derivative. As the answer is negative, it's a local maximum at x is equal to 1. So, quotient rule. U is equal to e raised to x. V is equal to x. What is the derivative? What is the derivative? This 1. So dy by dx. Your derivative is v into u dash minus u into v dash over v square. You have to make this equal to 0. If you remove e raised to x, x minus 1 upon x square is equal to 0. So e raised to x. So e raised to x is equal to 0 or x minus 1 is equal to 0. So remember, e raised to x is your exponential graph. It doesn't cut the x-axis, so no solution. So x is equal to 1 is the only solution. So there's a stationary point at x is equal to 1. Now the next step is classifying it. To classify it, we take the second order derivative. My first order derivative, we got over here, if I remove e raised to x common, it's x minus 1 upon x square. So u is equal to e raised to x, x minus 1. Your v is equal to what? X. Now when you're doing this will be product rule. So you keep v constant, take the derivative of u, plus you keep u constant, take the derivative of v. You can do it in one step like this. You keep v constant, take the derivative of u, which is e raised to x. plus now you keep this constant, take the derivative of this. So e raised to x we kept constant, derivative of the, yeah. So that's I did it in one step. So what will this become when you open the bracket? X e raised to x minus e raised to x plus e raised to x. This and this cancel. What's your v dash? 2x. So therefore d square y by dx square will be v into u dash, correct? So that's x cube e raised to x, correct? No, x square into this, minus this into this, 2x e raised to x, x minus 1, divided by what? V square. Now what do you do is,
I remove the x only.
you can remove e raised to x common.
I remove e raised to x, so x e raised to x.
X e raised to x common. Okay, fine. So you'll be left with x square minus 2x, x is gone common, minus 2 x minus 1. Correct? So this and this will cancel. So x cube. So e raised to x square minus 2x plus 2 upon x cube. Check. This is what you should do. Now what you do is you substitute that answer that you got, x is equal to 1 in this.
Yeah.
D square y by dx square, if you put x is 1, e raised to 1 is e, 1 minus 2 plus 2 upon 1 cube, so which is e. This is positive. Therefore there's a local minimum at x is equal to 1.
Okay, I made a mistake.
Yeah. Local maximum at x is equal to minus 4. Okay. Now first thing is you have to find out a. Now when it is a local maximum, you take the first order derivative. Correct? That's 2 into 3x square, a into 2x, correct? Minus 24 into 1. So your first order derivative will be 0 at a local maximum.
Yeah.
So when x is equal to 4, 3 to the 6, 4 square, minus 4 square, sorry, at minus 4, 2a minus 4 minus 24. Basically, the derivative at minus 4 will be 0 for local maximum, na?
Yeah.
So 6 into, this is 4 square 16, minus 8a minus 24. 96 minus 24, that's how much? 72. So 72 minus 72 is equal to minus 8a. 8 9s are 72. So a is equal to 9. Equation. So my original equation is, now we know the value of a. 2x cubed 9x square minus 20. You can use your calculator, please. The numbers are big.
Yeah, huge numbers.
Yeah, huge numbers. So you put your minus 4 cube minus 4 square minus 24 into minus, because in IB they'll give you this with calculator. 113. So that means you have to write the coordinates. So the coordinates will be minus 4 and 113. So when they ask you coordinates,
Yeah.
this is how you write. But it's a long sum. So let me do it over here. The stationary point. So your y is equal to e a raised to x upon dx. So u is equal to e a raised to x. V is equal to bx. So u dash is e a raised to x into chain rule into a. Correct? V dash is b. Correct? So y dash, or your teacher wants dy by dx is equal to v into u dash. So abx e raised to ax minus vu dash minus b e raised to x upon b square x square. Correct?
Yeah.
Now this is equal to 0 at x is equal to 1/3. This is the coordinate. Na? The derivative at that point is 0. Once you put your x as 1/3, so you can remove b e a raised to x common. Correct? You'll be left with ax minus 1, isn't it? ax minus 1, and this will multiply. And you put your x as 1/3. So be a x is 1/3, a x is 1/3 minus 1 is equal to 0. So b is equal to 0, or e raised to a third is equal to 0, or a upon 3 minus 1 is equal to 0. Now this is not possible because it's in a denominator over here. Correct? So b can't be 0, the function won't exist. This is no solution.
So it's
No solution. Okay. And this one, what will happen for this one? A upon 3 is equal to 1. So a is equal to 3. Now to find the value of b, you put it back in the original function. So that means my function is a is 3e raised to 3x dx. Now my point is 1/3 comma e by 2. So that's my x and that's my y. So y is equal to e by 2 is equal to a 3 into 1/3 b x. Correct? This and this cancels. Cross multiply. So b upon 3 into e is equal to 2e. E and e cancels. So b is equal to 6. Perfect. What you've done is perfect. So that means what my function becomes is y is equal to e raised to 3x upon 6x. That's my function. And what does my derivative become? My dy by dx becomes ab. So a into b. So 3 into 6 x e raised to ax minus b is 6 e raised to 3x upon b square x square. B square is 36. So 6 3s are 18. X e raised to 3x minus 6 e raised to 3x.
oh sorry, the next.
No, they're not like terms. You cannot combine them.
So but it was 18 e raised to 3x minus 6 e raised to 3x. It can become 12 e raised to 3x.
But it is not, na?
No, so I'm asking if it was because there was somewhere.
Obviously, na? Obviously.
That's good. That's good.
Because they're like terms, no?
Yeah.
Don't, I mean,
So you can take e
you know,
raised to
people
3x
don't.
out.
E raised to 3x also you can take out. So 6, I just wanted to cancel this now. Wait. So now what do? You can take the second order or you can do the sign diagram to get the nature.
I will take second order.
Second order will be bigger. If you take the value, it will be much easier.
How do you get the value for this of paper 1?
Why? If this is 1/3, stationary point is at 1/3. Correct? This is your 1/3 is the stationary point. So take a value less. So I will take dy by dx at x is equal to 0. So if I take 0 minus e raised to 0 upon 6, you can't take 0 over. Because you're dividing by 0, you can't divide by 0. Second order derivative. So it becomes a very long sum. Leave it. Leave it.